Hello! Today I'm going to be speaking about deriving some derivatives from our tables. So how do we prove that sine of x equals cosine of x, and how do we prove that the derivative of cosine of x equals minus sine of x? So essentially what we do, we follow the same formula that I showed you in my previous videos on derivatives, so please go check them out. And we use a trigonometric expression. So here we have a sum inside of our arguments, and I've shown you in my trigonometry videos how to deal with this. So we just rewrite our sine function. Again, we have sine x plus some small nudge minus the point before that. So I'll just rewrite it. So sine of x times cosine of delta x plus sine of delta x times cosine of x minus sine of x. And now what we're going to do, we have to know some basic limit laws, so we know that if x approaches 0, sine of x divided by x equals 1, 1 minus cosine of x divided by x equals 0. I'll explain this in another video, but for now, those are the results. Please go check them out or try and prove them for yourself if you feel up for it. So, I'm going to rewrite this in a different form. So I'm going to write is sine of x times cosine of delta x plus sine of delta x, or let's just skip a step. Let's just do it like this. So what I'm going to do, I'm going to highlight it in another color. So since sine of x divided by x, the same argument, so you can substitute this for u or delta x equals 1. I'm going to want to separate this from the rest. Can I do that? I've got a plus sign here and minus sign here, so yes, I can do that. So sine of delta x times cosine of x divided by delta x, and we are left with, we've got sine of x on both sides, so we can multiply by sine of x. Cosine delta x minus 1 delta x. We want this to be in the form 1 minus cosine delta x, so we can do, we can change the sign to minus. And therefore we will get 1 minus cosine delta x. This whole thing is sine of x times 0, which is 0. Sine of delta x over delta x, if we separate this, we get 1. And 1 times cosine of x is cosine of x. That is our proof that the derivative of sine of x equals cosine of x. Now, we're going to prove that similarly, using the same technique. So you can do this, you can pause the video and do it by yourself if you wish to. If you don't, you can do it with me. So we are going to prove that the derivative of cosine of x equals minus sine of x. Again, using the equation I showed in my trigonometry videos, we'll rewrite this. That's delta x, yeah. So cosine of x times cosine delta x minus sine of x times sine of delta x minus cosine of x all over delta x. That equals limit as delta x approaches 0. And what can we do here? So we've got cosine of x here, cosine of x here, so we could group that together and get cosine of x times cosine delta x minus 1 over delta x minus sine of x times sine of delta x over delta x already know this is 1 times sine of x, and if we rewrite this with minus cosine of x, that's 1 plus minus cosine of delta x, which is the same as our limit, so this goes to 0. We get minus cosine of x times 0 is 0, and we get minus sine of x. So that is the derivative for cosine of x. It's minus sine of x. It's quite easy. Now what I want you to do is prove these two statements. If we sum two functions, derive them, it is equal to the functions derived but separated. Or if we multiply two functions, it is equal to this. Can you prove this? If you can't, then I'll show you how to prove it. So what we do with the first statement, we just write it in exactly the same form. F plus g x minus f plus g a. F plus gx is further than a, so you could picture this as x plus dx, and this just being x. Okay, I'll just write that there. So again, we're subtracting the functions nudged a bit further from their previous points. A very tiny nudge though, a very tiny difference. Which is what calculus is all about, essentially. So we'll just rewrite that. We can rewrite this using some basic algebra. F of x plus g of x minus f of a times g of a. Sorry, f of a minus g of a. Then, since we have minus signs here, we can separate this into two pieces. We get f of x minus f of a over x minus a plus g of x minus j of a over x minus a. So we know this is the derivative of g at the point A. This is the derivative of f at the point A. So we've just proven that this is true. In the next video I'm going to show you how to prove this, and I'm going to give you a bonus proof for another rule in calculus. So stay tuned, please like, share and subscribe. See you guys next time.